This is the part 2 of my DIY force feedback wheel using open FFboard. Do check out the first video. This is the popular RC775 DC motor. It is one of the cheapest motors available. So I'll be connecting this BTS7960 DC motor controller, and first step is to connect this with the power supply and then to the motor. M is for motor output in, and there's B is for power supply, and M is for motor. So B for power, M for motor. I'm now first connecting the wires for the motor output, and it's pretty easy to remember which one is for motor and which one is for power. Right now I'm just not worried about which is positive or negative because I have not yet connected things. So if this is not in order, I can swap them later on. Okay, so this is for motor output, blue and white. Now for power supply, I will connect the other wire. Okay, this is pretty easy. This is done. Power supply, motor. Now I'll be connecting motor to the other end. Okay, let it be just like this, and I have a 12-volt DC adapter connected without cutting the wire and soldering as of now. So when I connect the power socket now, I don't think it should work because the controller is not yet enabled, and controller doesn't know whether to supply the power to motor or not. It's plugged in, but I think when I complete the circuit by connecting it to the STM board, then I think we should get the motor working. Okay, now let's connect the motor controller to the STM board. Now we have 4 pins over here on the controller, which are basically your VCC, ground, L PWM like for left channel, R PWM for right PWM channel, and let's connect this to our board over here. The pinouts we'll have to see from the documentation, and I will try to stick with a similar color code like red for VCC, red for VCC and black for ground, and then green and white for the channels. The first one says VCC, so I'm just taking this red one and putting it to the VCC. The black one goes to the ground. The green and white ones are for the PWM, which tells the direction. Okay, now to the STM board. Red one goes here. First two are ground, and then next two are 5 volts, which is VCC. So VCC is the red one, ground is the black one. Let me explain the motor wiring to this STM32 board. Here it's very simple, we don't have any confusion. M is for motor plus minus, and B is for electric supply, the voltages, external voltages. I have connected it to the 12-volt DC adapter. Then here it's something that we need to pay attention to. Total 6 wires are here, and how they are connected is red and black is very simple. Red is for VCC and black is for ground. Now these two, which are green and white, and green and white are here REN and LEN. They are together combined with the red one, which is the VCC, which is the 5 volt. Okay, so green, white and red, green, white and red, REN, LEN and VCC, 3 are combined. Red, black, green, white are combined. Then we have this PWMs, which is yellow and orange. So here you can see there is RPWM and LPWM. RPWM is our yellow one. It is connected to PE11, and the orange one is connected to PE9. Orange one is LPWM, and the yellow one is RPWM. So PE911 are they connected to. Now the next steps are to create a base for housing motor, encoder and a way to mount the steering wheel finally. This involves working with some of the hardware. After this, I ordered lot of items like 5mm shaft, pulleys and belts. Some of these items went waste because I wasn't sure of what exact design I would want to make it. But if I have to do it like second time, then a lot lesser of these items would be required actually. To hold the ball bearings, I custom designed these mounts and 3D printed them. Okay, I think I did some mistake while designing. There was supposed to be some kind of border over here, but let's give it a try. Let's see how it is. This is the final product, and the steering wheel I got is for dirt cheap. It is some Nintendo Switches accessory, and I have been able to fit it using a drill bit. And these are my 3D mounted ball bearing holders. 5mm shaft over here. This is the motor driver, motor, STM32 board, encoder, and I had some extra wire, so I just wrapped it around over a PVC pipe over there. And I don't have the pedals. What I did is like I have just used these switches for accelerator and brakes, and I'm testing this using iRacing force feedback utility. Let's see this action next. With this, you can't really go into actual sim racing competitions, but this is pretty fun to be playing casually. The best part about it is the cost of entire thing is not even $100. Thanks for the awesome community of FFboard. Special mention to them. They're pretty nice and helpful.